Okay, now let's look at how we can apply the Pythagorean theorem. Where can we actually use this? That copied over really oddly. Since the Pythagorean theorem is true for all right triangles, and they have to be right triangles, we just saw that, we can write an algebraic equation to describe it. It is typically written as a squared plus b squared equals c squared, where c is the hypotenuse. So it would usually be ab, and this would be c. The textbook uses h instead of c. It does help make it a little more clear that we're describing the hypotenuse. But you'll need to know that when you go on, most places write it a squared plus b squared equals c squared, and that'll be how it's described typically. Most important thing to remember is that these letters are not necessarily what the sides will be named. So for example, I could call this R, S, and Q. I could really mess everybody up, and I could say, my computer still hates me, I could say that this is A, this is B, and this is H. I could call them whatever I want. When I plug them into the formula, this has to be the number that goes in for H. It always has to be the leg squared plus the leg squared equals the hypotenuse squared, no matter what letters they get called. I personally don't try to do that because I don't want to mess you guys up, but sometimes teachers will call them things like they'll take the hypotenuse and call it A just to see if you're paying attention. It's just a really good thing to remember. Okay, so let's look at some examples. So for example, we got Marina. She helped her dad build a small rectangular table for her bedroom. The tabletop has a length of 56 centimeters and a width of 33 centimeters. The diagonal of the tabletop measures 60 centimeters. Does the tabletop have square corners? How do you know? Okay, so this is a method that could be used in construction to see if your corners are square. Actually 90 degrees. Now, we also have squares for that. But, you know, say you happen to not have it along. So this is 33 cent. Let's change that. That's 56 centimeters. This is 33 centimeters. And the diagonal is 60 centimeters. So look, we've got actually two right triangles that are congruent. They're actually identical. And so let's just look at one of them. Let's change our color. I don't know why it has to do that. So let's look at this triangle here. So if that side's 33 centimeters, that side should be 33 centimeters as well. So I've got 33, 56, and 60. So I need to know 33 squared plus 56 squared. What does that equal? And I'm going to compare that to 60 squared. So 33 squared, I have no idea. 33 times 33 is 1089. 56 squared is 3136. And I add those together, I get 4,000. I get a pen that doesn't want to write. 4,225. Without even checking 60 squared, I know right away they're not going to be equal, because if I multiply a number ending with 0 times a number ending with 0, it's going to be 0. But anyway, it's 3,600. These are not close. The tabletop does not have square corners. So that means they're not 90-degree angles. You could say because the Pythagorean theorem doesn't work, they're not a Pythagorean triple, because when you add up the squares of the legs, it doesn't equal the square of the diagonal. however you want to describe it. I'm going to write the Pythagorean theorem does not work. Okay, and there's your answer. Next example, a snow ramp is used to load a snow machine onto a trailer. The ramp has a horizontal length of 168 centimeters and a slope length of 175 centimeters. What is the height? So I want to know this. And see, that would be a place where I might write an h, not the hypotenuse. So let's not call it an h because that might just mess me up. I'm going to call it b. So I know that 168 squared, this is going to all mess up again. Oh, maybe it didn't. 168 squared, so if I took the square of that and I added, oh look, there it is. Just a delayed reaction. I've added that to b squared, whatever that would end up being. So this little square here and this square here, okay? I know if I add those two up, it's going to equal 175 squared. Because I can see this is a right angle. Oh, and they called it A. So let's change that to A. Okay, so this square here is the same as this square plus this square. So then this square has to be this square minus this square. So I know a squared is going to be the big square minus one of the other little squares. So 175 squared is a really big number, 30,625 minus 168 squared, 28,224. And if I subtract those two, 2,428. Okay, but I don't want to know what the area of that square is. I want to know what the height is. So, as we said before, that means I'm going to take the square root of that number. So 2,428, and the square root of that is, let's go to, does it say to the nearest anything? Let's go to the nearest tenth. It's going to be 49, it's 0.27, so that would round up to 49.3 centimeters. So now, I need to write that in somewhere, the height is 49.3 centimeters. There's your practice, extra challenge, and after that, you have the unit test.